Okay, this is Mr. Great Tech Review. In Mr. Great Tech Review Studio, you are highly welcome to this episode of our tutorial. This is tutorial, this should be tutorial 14. Okay, on this tutorial 14, we are going to understand Ohm's law and simple circuit analysis. Simple circuit analysis and Ohm's law. Simple circuit analysis and Ohm's law. It's not gonna be a programming class tutorial today. We are not going to do anything with our IDE today. I don't think we are not going to do anything with this IDE today. But in today's tutorial, we are going to see how some values we are using, how we got them. We use 320 ohms, 330 ohms resistors in line with light emitting diode. We are going to repeat that simple circuit, and we're going to see how we got the values and how we use whatever we are using. Light emitting diode works with 3 volts. So we're going to see how we got the resistor we are using with light emitting diode, how we arrive at that values, and how Ohm's law controls everything we are doing in electronics. That is it. So I want you to see a circuit, a voltage as a force driving the current, and the current as the water flowing in the tap, and the resistor as the tap head used to reduce the pressure of the voltage. So the tap head, or the valve, the valve, when it's half open, it's fully open, and no restriction, current flows, which is the water flowing in there, something like that. I wanted to see circuit analysis like that. I wanted to analyze every electrical circuit, analyze it that way. So you see it that way, you'll be able to understand the rest of the story behind circuit. Okay, so we go to Ohm's law. We start with the Ohm's triangle, which everybody knows about the Ohm's triangle. For information, if you don't still have this, better get it. Very, very important. I know why I'm hammering on it on every tutorial. I still have to say it, I still have to repeat it, so that maybe it was sinking, so that you get it for yourself, because without it you are missing a lot. By the time we got to tutorial 30, 31, thereabouts, short from 20 upwards, you find out that you cannot cope without this. So do yourself a favor and get it. And if you might ask yourself where I'm getting most of my information I'm using to teach you, okay, it's a collection of information for a long decade ago. And when I was in high school, I used a book, a simple book that is about 100 and something. Is it up to 100 and something page? Okay, let's call it 100 pages. The simple book is 104 book. It's a very old book. I used it in high school. It's basic electronics. I use this basic electronics. This is how it looks, and this is how it looks. Basic electronics. A very old book. I bought it in the market, and I use it to understand electronics. It is actually called basic, and it's basic. So when I get into the higher institution, I also use this to complement. I use this basic electronic principles 6th edition Malvino. This is just what I got in the market, and that was what is available for me to get in the market. I used that to brush myself up, and I have gone through these books from front to the back, and all of that. So that is it. And this basic electronics is in series. In series, have 1, 2, 3, 4. I think stopped at 5. That is the ones I can lay my hands on. Okay, stop at 5. So that is, by the way, so you can do yourself a favor. You get it 1, 2, 3, 4, 5. You digest it. This is enough. This is enough for you to understand the basic principles of electronics. This is enough. And if you do all the projects in this book, you are done. You are just done with this book. Every university student, you hire a polytechnic, monotechnic, technical school, just get this. It's a practical oriented book. It's not too complex. They don't speak to models to know exponential equation, calculus, and the rest of them, and differentiation here. Just a very simple basic circuit analysis. Ohm's law. Finish. That is just it. So if you can be able to get this book and do yourself a favor, it's available in the market. Okay, let's go and see and some basic calculations, how we arrive and all these things we are talking about here. And okay, so get a fresh book and let's dive in and see how we can be able to do some of the things we are doing. Okay, so you have Ohm's law and you have the Ohm's triangle. You have this. Okay, you have it like this. You have V, you have I, you have R. So very simple. Very simple. Very, very simple. So that is it. Very simple. You have let me put picture in picture so that okay, use camera to okay, good. So now you have a Ohm's law, you have the Ohm's triangle where you have V over R, that's in the triangle, and the very symbol, it simply means that when you want to get I, you do I equals V here over R, and when you want to get R, you simply do R equals to V over I, and when you want to get V, you simply do it's a very simple multiplication of the other two. You simply do I times R, that gives you V. So it's very simple when you use the voltage, the Ohm's triangle, Ohm's law. Okay, Ohm's law. Now it's a very simple. Resistors are being measured in ohms, and current is being measured in amps, and voltage is being measured in volts. So that is it. So when you have resistors in series and in parallels, let's do some calculations and see how we got what we are using. And you see, you have resistors in parallel. This is parallel. Let me use the symbol of resistor. You have this as resistors is in series of a circuit. This is voltage, this is 5 volts. Let's use this voltage. This is 5 volts, and you have this is let's say this is 200 ohms, and this is 100 ohms. So when you have resistors in series like this, so the summation of the resistance here should be what? This plus this is half. This is R1, this is R2. So the summation of the resistance here is what? Is what? Resistors in series, resistors in series. You have R1 plus R2 equals RS, resistors in series. So that is it. So you have 200 plus 100. So this is, you have 200 plus 100. You have 400. You have what? 300. Sorry. You have 300 ohms. So that is it. Very simple. You have 300 ohms. That's how to get it. So what happens when you have resistors in parallel? This is how it works. Resistors in parallel. This is how it works. The law says when you have resistors in parallel, you have resistors like this. You have resistors like this in parallel to a voltage. To a voltage, you have 5 volts. How do you get to resistors in this thing? It's very simple. Resistors in parallel. So you have R1, you have R2. Let's use the same. R1 is 200 ohms, and R2 is what? 100 ohms. It's very simple. So when you have it, it simply says that the summation of the resistance is equals to the R1 multiplied by R2 over R1 plus R2. Very simple. R1 multiplied by R2. So the summation resistance, the resistance in parallel. So the resistance in parallel, RP, is equals to R1 times R2 over R1 plus R2. So very simple. In this place you have this, bring it down here. So let's go where we have space. So in this place, what we have here, we have R1, which is what? 200 plus 100. Sorry, 200 multiplied by 100 over what? 200 plus what? 100 plus 100. So plus 100 plus 100. So it's very simple. You use your calculator. So I use my calculator. So it's very simple. Okay. So that is it. Now you have 200 times 100 times 100, sorry, 200 times 100, you have 20,000. You have 20,000 equals to 20,000 over 200 plus 100. 20,000, 200 plus 100 is was 300. So that is it. So now that is it. So you have 200 plus over is 300. So you do your mathematics. That is 200 divided by what? 3. So you have 200 divided by 3. 200 divided by 3. 200 divided by 3 divided by 3. So you have 66.6. So you have what? You have what we have here is still RP, R parallel, summation of the R parallel, summation of the both of them is RP is equals to 66.6 ohms. So that is it. That's a very simple way of getting those resistances. So now we are going to see once we have calculate them based on the current and see how we got what we and how we, let's see, when we apply let's make a very simple circuit and calculate and use our resistors and see what values of current how can we get the current and see. So we have seen how we got the voltages and the resistances, resistance in series and resistance in what in parallel. So that is it. So when we want to get the voltage across this point, and also voltage across this point, the V across this point. So how do we get it? How do we get the voltage across this point? So that boils down to our calculations. So now we see, let's do some practicals and see how we can get them using our resistors in our kit. So now let's use our resistors in our kit and see how we can get them with our formula here, with this formula, which I will still boldly write. Let's see. So this formula, I equals V over R, and the R equals V over R. What am I doing? V over I. That is R, and the I equals V over R. Then we have the V equals I times R. Okay, sorry for this. I think I made a mistake here. R equals, on this place I made a mistake here, it's supposed to be R equals the V over I. Okay, so that is, by the way, that's a mistake, I didn't see it at the beginning. Okay, now so that is it. So now V over I. Okay, so now how can we, let's form a circuit and see how we can get the voltages across the resistance in series and the, let's see, I think I have 470 ohms resistor. So this is 470 ohms and 100 ohms resistors, and okay, this is 470. So if you don't know how to read color coding, think it's another topic of its own. You can use your meter and switch it to resistance, and you can now test it. Hold one side as your resistance and you read the other side of this, and you have 467. Okay, it will not give you exactly actually this thing, but it will be very close to it. So now let's see and see. Let me read it and see. 467, that is 470. For 470, then 100 ohms will give you, and this is how you do it. You hold it with one hand and the other leg do it like this. So let's see what the meter tells us. So okay, 99.2 ohms. Okay, so two of them, we are going to use them to form our basis of circuit. So now we go to our breadboard. We normally use our breadboard. Now we connect them, then we connect them in series, just like we said. So let me just draw the circuit diagram so that we can go ahead and make our connections. Okay, so now we have a 470 ohms. Okay, so we have this. Okay, five volts. So, okay, so you have plus, you have minus. I could have used a different color. So you have this 470 ohms, you have 100 ohms. So this is R1, this is R2. So that is it. So now we go ahead, 470 ohms R1. So normally, you know how you can use it. So I will disconnect this so that I will not confuse you. I will disconnect this one of our program. This is out. This is gone. Let me drop it somewhere. I'm not going to make use of it. So let me drop this so that we can be able to. Okay, and drop this in. Okay, so now let's see. So 470, very simple. It's 470. You push it to the in series. Okay, with the circuit. This is plus circuit. You put 470 here. Okay, then you put 100 to the ground. Okay, to the ground. So it's very simple here. See what I did? In series, you have the first. So, okay, so that you understand, you see it very clearly. So you have plus, you have the 470 ohms. Okay, now connected in series with the 100 ohms resistor. So you have this at 470 ohms, then you have this as a 100 ohms resistor. So that is it. So now we going to do very simple. You use our red to the positive side of it, is the positive side, then you use the black on the negative side of it. So very simple. So I can go towards this end, and then I can go towards this end. So there I supply it with my 5 volts from Arduino. So now we do our calculations to read the voltage across and see how we can get so in our Arduino board, just like I told you, I'm not going to power it with the system. So we're going to select 5 volts from the 5 volts board. From this 5 volts, where we see 5 volts output pin. So this is the 5 volts output pin. So there's a place written 5 volts. You can see it. Okay, 5 volts. You have 5 volts ground, you have 3 point something volts, you have 5 volts ground. You have 5 volts ground, you have 3.5 volts, you have reset. So from the 5 volts we collect our 5 volts, and from ground we collect ground. So that is it. So now we tap our 5 volts from 5 volts. 5 volts, 25 volts. And we tap ground from ground. So that is it. From 5 volts we tap 5 volts, then from ground we tap ground. So that is it. See, so this is how I'm going to set it up. So this is very simple. And then you plug using my USB distribution. This is just a USB dock. I can tap my 5 volts, connect my 5 volts, or I can use my 9 volts battery with my cap, and they connect my Arduino without connecting the USB. So I can use my 9 volts cap, connect my Arduino without. So here I have a 5 volts. I have 9 volts, and let's check and switch your meter to voltage, DC voltage. Switch your meter to DC voltage. So that is now I read the voltages. The in is the positive, while the out here is negative. So you can see from my meter, you see I have 9.5 volts. So I use it to power my Arduino from here, which has a regulator that brings it down to 5 volts. So Arduino has a regulator, a voltage regulator that will bring the 9 volts to 5 volts. So that is it. So I connect it, so it's being powered now. As you can see, it's being powered now. So you can measure from here to here, from the end to the end of the pin. I have 5 volts out. So now I can measure this end. So I can measure this end, this end to this end. So this end to this end, I measure this end to this end, I'll have 5 volts. So that is it. So now I can show you from my meter my voltage. You can see 5 volts. So that is it. So I take it. So now let's see, without using meter, then we use meter, we check and also see. Without using meter, we can now calculate and see the voltages across this resistance using the Ohm's law formula. So that is just simple. To tell you that the formula works, it's a very simple thing. So I have 5 volts, across the board. So now I will remove my power so that I don't want to power my Arduino for a long time. So I have this. So using the voltage across, so let's get the current across this okay, so when we look at the circuit here, now we see we have from the diagram, from the practicals, from the variable, from the breadboard, we can see the series. We have the two resistors in series to the voltage across the voltage potentials across the plus and minus side. So now we represent them in diagram. So we have this as the diagram. So we have this. Okay, so we have this. So okay, have minus plus 5 volts, 5 volts. So we have R1, R2, which is 470 ohms, which is 100 ohms. So the combination of the resistance in this circuit is R1 plus R2, which is equals to 470 plus 100, which is 570 ohms. So I have 570 ohms in the system. So now we are going to get the current across this resistance, these resistors. Now the current across this resistor is supposed to be, we use our this. From our formula we have I equals V over R. So supposed to be V is 5 volts, so I equals to 5 volts over R resistance, which is 570 ohms, which is equals to 5 over 570 . Okay, 5 over 570. So 5 over 570 will give you, is equals to, my picture, am I getting it? Am I getting it? Okay, now I'm getting it now. Okay, so 5 over 570 is what is 0.00877 what 7. Okay, now multiply by 1000, that is amps. Multiply by 1000, because in Arduino we use milliamps. We use milliamps, so multiply by 1000 to get the milliamps value. So answer multiply by 1000 times 1000, so you get 8.771 milliamps. 8.77 milliamps. So we have our I equals to this or this. So I equals to this or this. So now, okay, so how do we get voltage across this resistance? This resistance. So voltage across this resistance is what? With our formula, I have V equals I times R. V equals I times R. So now V voltage equals V1, because the voltage across this, and voltage across this. So that is it. Now this is V1 and V2. So cool. So V1 is equals to R1. So V1 is equals to I1. This is the total I, summation of I times R1. So now, which is I is what? Okay, let's go by amps. I is 0.00877 times R 470 times R 470 ohms. So let's go. So 0.00877 times 470. So it have, so equals to, it have 4.1219 volts. So it's 4 volts. So okay, now my paper is filled up. So let's go again. So V2, this is voltage across. Okay, so V2 voltage across the resistor 100 ohms. So it's what? It's equals to summation of I times V2 times R2. So which is and our I is what? 0.00877 times 100 ohms. So times 100 ohms. So I have what? I have V2, I have 0.877. So when you add these two, you have to motion of, you have 5 volts. You have 4 point, you have plus 4.1219 volts. You will have 5 volts. You have 5 volts, which is summation. So plus, so answer plus 4.1219. So okay, we have okay, I'm getting 4.999 approximately 5 volts. So I have 4.999 approximately 5 volts because I didn't add all the decimal points in the former listing. Okay, so that is it. So this is how we can be able to. So when we measure now across now, so this is the summation, the voltage summation V2. So now V2 is what? Is 0.8 volts, and V1 is what? Is 4.12 volts. So let's see the voltages across this and see whether we are what we got on our calculation is the same thing we got on our with our voltmeter. Let's read it with our voltmeter. So let's see how we got this. So now I have my voltmeter set in volts. Okay, in DC volts. So this is it. Then I have, how am I going to do it now so that you see exactly what I'm doing? Okay, I think it should be better this way. Okay, now let me bring this and bring this like this. So now you have the voltages across like just like I measured before. The voltages across is what? Is you have 5 volts. Then the voltage across the first resistor, this is, I have 4.1 volts, and what we got is what? What we got is 4.12 volts. So that is it. So we are correct on our calculation. What we got on our calculation and what we got with the voltmeter is the same. So this is, you see it, this is it. So 4.12 volts, 4.1 volts. So now voltage across resistor 2 is what? 0.8. Exactly what we got here, 0.8. So that is it. That is a simple circuit analysis, Ohm's law. We have demonstrated Ohm's law in our circuit. So on our next tutorial, we are going to, and our next tutorial will be very easy for us to understand, because we are going to read analog voltages using analog read command, and we are going to exactly make use of this circuit to read our analog voltages using our our analog command, analog read command. So we're going to supply a voltage to a circuit and we read it through the Arduino. Now we are reading it through what? Through the voltmeter. Reading it through the voltmeter. We are now going to read it through the Arduino analog read command. So we are going to read it from our analog port, analog A port. Maybe we'll use A1, analog A1 port to read these voltages we have read with our voltmeter. That's just the simple thing. It's just for us to read it. Using our serial monitors, we see the voltages reading. We see the voltage. We see the voltage as it's fluctuating. By we're making voltages adjustment, we see it is fluctuating. So that is what we're going to do in our next tutorial. Okay, so that is it. So, and it's a very simple and easy calculation, but just you have to understand simple basic Ohm's law for you to be able to do this. And do yourself a favor by reading this book. It's going to help you. It's going to help you. And that is it for now. And this is where I will call it a day. Once again, I'm your one and only Mr. Great, bringing you technological updates, Arduino updates. And here in Mr. Great Tech Review Studio, where we bring technology close to your doorstep, we are here to serve you. We are here to give you updates. And you are not going to pay a dime for this tutorial. This tutorial is free of charge. So this is my own contribution. And just do yourself a favor, get all it takes to do this program, your kits, your Arduino kits, and your voltmeter, your multimeter, and you come along. Let's explore the world of tech. This video makes sense to you, like and share and subscribe so that others will benefit. And also join me on my YouTube channel. Subscribe, like and share so that others will also benefit. Just I will always say others will benefit, because every information you got, maybe you heard it from someone else and someone else shared it with you, or you saw where someone else posted it, or you somehow you jam a material and you pick it up. It's someone that drops it there. It's somebody's work. You didn't just get it by thinking. So that's why I always say, if it makes sense to you, you share so that others will also benefit. Don't try to hide knowledge. It's not good. Hiding knowledge is not good. Whatever you have, you share it. The more you teach, the more you understand, the more it makes sense to you, the more you learn. So I like teaching people electrical electronics right from my time in school. I organize inverter tutorials, I teach inverter tutorials, solar energies and rest of them, and it made me so conversant and so grounded in anything that has to do with inverter, solar stuffs and rest of them, and solar energy generation. So because the more I teach, the more I do more research, the more I understand the stuff. So find it, just have the habit of teaching whatever you know, sharing it with people. It will also expand your knowledge and you will go far. So thank you very much and God bless you. Like and share this video. God bless you. Bye bye for now. I'm your one and only Mr. Great.